Okay, in this example, it says the number of hits to a website follows a Poisson process. Hits occur at the rate of 1.4 per minute between 7 p.m. and 10 p.m. Given below are the three scenarios for the number of hits to the website. We want to compute the probability of each scenario between 7:49 p.m. and 7:53 p.m. and then we're going to interpret each result. Now, if the random variable x follows a Poisson process, we can use the following probability rule to compute Poisson probabilities. Here is the formula. P of x is equal to lambda times t to the power of x over x factorial times e to the negative lambda times t, where x can be equal to 0, 1, 2, 3, and so on. Lambda represents the average number of occurrences of the event in some interval of length 1, and then e is approximately 2.71828. Now here we can see that lambda represents 1.4 and t is going to equal 4 minutes because, and let me go ahead and highlight that two information. We know that lambda is going to equal 1.4 and t is going to equal 4 because we need to find the difference between 7:53 p.m. and 7:49 p.m. So when we subtract those two, it gives us 4. All right, so if we went ahead and then plugged it into the formula that we have up here, then we would get the following. We would see that you take lambda, which is 1.4, and multiply it by t, which is 4. So therefore, when you would find this result, okay, that means that the value of the mean, because it's the same thing as the mean, would equal 5.6. Okay? So what we're going to do, okay, is that if we plug this into our formula and find the probability of that formula, we would get the following result. Let's see what happens when we use StatCrunch. So in order to use StatCrunch, we're going to go to Stat, we're going to select Calculators, and then go all the way down to Poisson. Okay, so when we use the Poisson, we need to make sure that this is grayed out where it says Standard. And so you see here where it says the mean, we're going to put in the mean of 5.6. So we're going to put in 5.6, and then this says exactly 5. So if it's exactly 5, that means x has to equal 5. So we need to be careful on how we're putting this in here. And then we're going to put the number 5. And if you notice, we get the same probability that we get here, which is 0.1697. And so therefore, what we would do is, we would rewrite this as a fraction, round it to 2 decimal places, which is 0.17, which would be 17 over 100. Okay, so what does that mean? That means that about 17 of every 100 time intervals between 7:49 p.m. and 7:53 p.m., the website will receive exactly 5 hits because it's asking exactly 5 hits. So that's how we get exactly 5 hits. Okay. All right, next, it says we want to calculate where it says fewer than 5. Well, calculating the probability of less than 5 occurrences by calculating the sum of the probabilities of all occurrence values that are less than 5. So we would say the probability of x being less than 5. So let's go ahead and do that on StatCrunch. So we know our mean is going to stay at 5.6. But now what we're going to do is we're going to say, okay, we're going to say less than 5. Now remember, less than 5 is the same thing as less than or equal to 4 in our problem, right? So we're going to select compute, and then you can see what we get for our probability. Let's check with our formula here. When we plug in our formula, excuse me, we can see that we round this to 4 decimal places, which gives us 0.3422. Now, yes, we would find each particular probability, which would take a little bit longer, but it's still important to understand using StatCrunch and how this represents what our formula would look like. And so therefore, that verifies our probability. And so if we wanted to round this to 2 decimal places, we get 0.34, which is the same thing as 34 over 100. So we would say that on about 34 of every 100 time intervals between 7:49 p.m. and 7:53 p.m., this says fewer than 5. We will receive fewer than 5 hits. Okay, next, this says at least 5. We would use the complement rule to obtain the value for an at least probability for a Poisson process. Now remember that at least is the same thing as greater than or equal to 5. And the opposite of greater than or equal to 5 is less than 5. Okay, so let's do this in two different ways. When we look at the formula, okay, we're going to look at the fact that we have greater than or equal to 5. So if we change this inequality to be greater than or equal to 5, then we're going to get the following probability, which is 0.6578. Okay, so we would see that that's the probability. Okay, so there is our probability. Now another way to look at this is we're going to take 1 and then subtract x is less than 5. So if we wanted to figure out what is the probability of x being less than 5, we can also get that number. So if we put in less than 5, okay, you can see that we're going to get the same result that we get over here, which is 0.3422. So 1 minus 0.3422 would give us the same probability. Okay, and so now we can say that if we want to round this to 2 decimal places, this would be 0.66, which is 66 over 100. So we would say that on about 66 of every 100 time intervals between 7:49 p.m. and 7:53 p.m., okay, the website will receive at least, and that would be 5 hits.